So in question 2 we get given a wooden block. There it is. It has a mass like this. It's on a rough horizontal surface, which means it's on a surface with some friction on it. This surface has some friction. The coefficient of friction between the block and the surface is 0.3, and this horizontal force that you can see is causing it to accelerate to the right. So the first question, A, let's draw a diagram. So you can draw a dot with arrows coming out of it, or you can draw the block itself. So I'm going to draw that block like this, and then let's put on the first thing that we know. The first thing is what's already been pointed out to us, which is this 30 Newton force like that. And then what we have on the other side of that, I like to do these in opposites, is the friction force. And the friction force, as we'll come to later, that's going to be this coefficient of friction, this 0.3, so 0.3 times by R. R we will come to in a minute. You don't have to write that down, by the way. You can just write down friction there, and that's enough for the mark, but we will come to that later, that R. So going down, we have gravity pulling down. We have the weight. Weight is the effect of gravity on the mass, and we can calculate the weight. We can say the weight is the 4 kilograms that we have. 4 kilograms times by 9.8, which is the effect of gravity. So the mass times the gravity, which is going to be the weight, which is 39.2 newtons. There it is. And then, like I say, I like to do these in opposites, but people sometimes forget this one. So going up, we have R. R is our contact force. R is what stops this thing accelerating downwards due to the weight. It's the contact force. So it's basically, if you put your hand on a table, it's what stops your hand going through the table. It's actually electrons repelling each other, but never mind that, that's too deep physics, I think. So the contact force there, that's going to be exactly the same as our weight there. That's going to be 39.2 newtons. And then this R is the same R that you use to calculate the friction, which we'll do later on. But basically these two have to be equal to each other, otherwise it's going to accelerate in one direction or another, either up or down. So let's do B. We've kind of done it already. Calculate the magnitude of the normal reaction force acting on the block. We've done that. It's there. That's literally it. That's all there is to it. It's there. So let's move on swiftly to C. I like doing that. Find the magnitude of the friction force acting on the block. Well, friction, F for friction force. Friction force is equal to mu times by R. Mu here is this 0.3, the same as this 0.3 here. So mu is 0.3, and we are going to times that. Let's choose another colour. We're going to times that by our R, our 39.2, or 4 times 9.8. It doesn't make any difference which one you write down in the exam. And then you times those two together, and I believe what you get out of that, bear with me, is 11.76. I think that's right, that is right, good. 11.76 newtons, that is our friction force. That's what's pulling it to the left, basically, and our 30 newtons is going to the right. So on the basis of that, find the acceleration of the block. So we have 11.76 going to the left, we have 30 going to the right. So let's find the difference between these two. What is the difference between those two? I'm going to get a calculator out here. Maybe you can do the same. I don't know if you have a calculator near you, but let's go for it. So 30 minus 11.76, 30 minus 11.76, that is equal to, so 30 minus 11.76, that is equal to 18.24. So we have a kind of leftover going right of 18.24 newtons. This is forces in newtons. So then, how do we calculate the acceleration? Well, F equals ma. F equals ma. So we have our F, so our 18.24 is equal to mass. Mass is up here, mass is 4, that's up there, 4 kilograms, 4 times by A. So let's divide both sides by 4, and if we do that, we will end up with a new colour. A is equal to 4.56 meters per second squared. That's meters per second squared acceleration. That's the end of this question. See you on the next one.